Hello guys, wonderful good day. I just thought we want to have a bit of a chat about Revit's coordinate system because that's commonly a bit of a confusion around. Let's see if we get a bit of a structure into this and how things actually relate to each other. So I'm Florian here and looking after you a bit after the channel, and yeah, so welcome, and just stay tuned. Hopefully I can answer a couple of questions here. So Revit actually has 3 coordinate systems. Sounds a little bit weird. Why 3? I would say just say it because the computer needs 3 actually to operate parametric. So first we have one here. It's called a relative origin. And from this relative origin, we have another one. I might use this here with a circle and a cross as it's the traditional symbol. Also called it's a project base point. So we have here a project, then we have here something called base, and then we have something called point with this. From this relative origin, we also have a survey point. So it's probably the symbol what we actually find. You probably will remember these symbols, and I will show you them in a second. They're commonly blue, but yeah, can happen. So this thingy is called survey base point. All the geometry in Revit, let's just make it gray like it would be a bit of a concrete, is actually stitched to our project base point. When we model our geometry, I have sometimes the feeling actually that it actually reverts back here from our project base point, and so when we move our project base point, then also all the geometry actually moves with it. Also all the imports, anything else actually moves with this, which is actually good. The relative point actually is needed when we actually move our project base point. It's a bit of a relative point relative to the survey point, because also the survey point can actually also move actually in our model. So we can actually set up here all kind of different variations. So having said this, some people probably have seen and heard that Revit is sometimes a little bit itchy when it comes a little bit to larger sites. Also when it comes to a bit to smaller sites. Let's see it like this. What's the smallest distance we actually can model in Revit is 1/32 inch, because the builder and the contractor, they don't care if it's smaller, which is equivalent to, I think, something around 0.7 millimeter. We can say basically here in our equation smaller Revit, smaller, and now it's getting a little bit interesting. I believe some people say it's about 32 by 32 kilometers, but it depends again where your project base point actually is. So it is actually from your project base point in a radius of equals 10 miles. So that's the maximum what we actually shall model here. So the question is now where people ask why is this? Did the programmer run out of numbers or all kinds of numbers? No, actually not. We know that Revit is a parametric solid modeler, and as a parametric solid modeler, maybe we can grab here a green color for our Earth. We actually have also some parametric parametric geometry in the Z value. For the computer, however, is the model we actually create is actually flat. In the real world, it's curved. So we have here a bit of issue. So when you, for instance, start modeling on this planet, it's somehow curved, and so which means so when we build now into the height, into the Z value, and after 10 miles we build also here in the Z value, then we probably notice that we would see here a little bit of difference actually, because for the computer it's basically flat. Use a good old Commodore sign here. Yes. So for the computer it's basically flat here. And so because of this, the computer also would produce inaccuracies when it comes to deciphering or building up any relationship. So between our coordinates and keeping our model actually, so to say, parametric. And that's why we have here an issue, a limitation actually of about 10 miles for that. So where the computer says, okay, in this kind of margin, in this kind of L, with this kind of delta here, I actually can work with this, and I can understand what my user actually wants to tell me, what data I actually should store. Good. When we now do an import from any DWG file, unfortunately, when we do a DWG import, for instance, unfortunately, these limitations also apply to this DWG file, because as soon as we bring a DWG file into Revit, the whole DWG file and all the elements and objects and all the lines become parametric to each other. So, for instance, what AutoCAD or Bentley or what others were they obviously cannot do, but Revit deciphers them and just connects, because R is about Revit, okay, and is about relationships, or Revit is about relationships, so to say. Okay, so if somebody asks, I practiced this for a month. Good. The strong R. We have here our DWG when we bring this in. So, but this is actually not too tricky and too difficult, because it is actually just about the geometry. We have a couple of options how to bring the geometry into Revit. We will understand and see this. So, when we now scroll down a little bit here, we should find that we have maybe here a DWG origin in AutoCAD 0,0,0 somewhere. The set value in our case doesn't matter much. It's actually just the X and Y we actually need, because of the extent the set values are actually basically suffering. So when I now go here larger than 10 miles radius, or 32 kilometers, basically 10 miles are actually 16 kilometers. 16 kilometers in a radius obviously create basically a circle. Draw this up here, where we have basically 32 by 32 kilometers, something around. Okay, so this is where the 32 kilometers sometimes come from. With the 10 miles. Good. And now we actually want to later on draw something, and we bring it a little bit further away than 10 miles. And actually we want to see that this actually works also in Revit here, so it's not a big issue. There are two things we just need to take care of. So after 10 miles, we might have maybe here, depending on our geodetic system, what we currently use, we might maybe here have a little bit our boundaries. Okay, so when we bring this in, this is actually not a big issue, because we could make use this as our project base point. When our project base point is down there, it actually doesn't matter much, because it's about the geometry actually. So if the survey point is actually, so to say, then in the end, then down there, it doesn't actually matter. If the geometry is somewhere else, it doesn't matter, because I just mentioned that if the project base point is basically down there, it means because we can actually import it, for instance, center to center, and then everybody is happy, and theoretically the origin would be then basically here in the center from our geometry. Okay. So I have this further away. So to practice this a little bit, we first switch a little bit to Revit here. I have here a Revit open, and for many to see is actually the first big question is, where's actually the survey base point, what is my project base point, and why and how do they actually work with each other. We find here with the standard default architecture template something called site. And here on the side, it actually these two can show up. When we go, for instance, here, let's just close this here, and let's make this a little bit larger here. Come on, be nice to me today. We find these two actually under the visibility and graphics. Instance parameter of my view. We can go here to my edit, and under the edit, we see that when we can open this up a little bit, it's always a bit entertaining. When we go here to our site, that we have our project base point and actually also our survey point. Tricky is when we have both turned on and the survey point is miles away and you do a zoom all, it obviously considers it as well, and then it might be that you zoom so much out that you actually don't see your project anymore. But never mind, can happen. So let's quickly turn them on here, and here are our two friends. down there. And what we actually notice is when we hover over it that they obviously highlight, and with a tab I can actually also highlight now my survey point. I bring my survey point away. So I can move my survey point around, can do this the whole day long. Alright, beautiful, don't really need time. So as soon as I go to my project base point here, so let's just move this a little bit further away that nobody actually confuses these two. So we have here project base point. As soon as we move my project base point away, absolutely nice, beautiful, cool. So there was a third one, that was the relative one. The relative point is actually, the relative origin is stitched and connected here to my project base point. And I have also with my survey point, I can also have here the office clip and clip, or basically unclip it to the survey coordinates here. So you see here, for instance, I can unclip it and actually can move this away. Okay, no earthquake, no anything is happening, nothing bad here. You see just that the coordinates update. So when we want to reset this, we set this to 0 and we set this again to 0. So fantastic. Having this set up here. Okay, and then when we clip this back on, then you see that it actually takes these coordinates with it. To have a bit of a play with to find the relative one, which is actually a stealth one, I would strongly suggest, and I would also extremely strongly suggest, that every Revit template has a few spot coordinates actually set up here. By default, or many default ones, that's just your spot coordinates horizontal. Now ideally, or I strongly recommend that every template has actually all three set up, because as soon as you need to find yourself in place or where you actually are, you find that Revit actually doesn't display any coordinates because there would be too many. We can actually use here, for instance, our spot coordinates and quickly annotate this, and then immediately it tells you where we are actually. So nobody knows at this point that my spot coordinates actually work from my survey point. Hence, we just delete this here quickly, and we just create a couple of spot coordinates. So here are my spot coordinates as our type parameters, and wonderful, good morning, and we call it just SP. SP short for survey the point. All right, and this one, if you want to keep this horizontal, is all good. The coordinate origin is here, as we see, is from the survey point as well. So this is a little bit mean, because we need to somehow clarify what coordinates we actually mean. And so what I would suggest, I just add here a kind of an SP in the beginning, and then another SP to the north, and then I go from the survey point, for instance, also east. We want to include my elevation because you have seen me here already adding an SP to the L. Wonderful, great. So if you have east-west, north-south, none, or whatever, we can set this up here. Sweet. So we go from the survey point. The survey point here, we can actually also verify. For instance, we have a bit of a variation here with different colors. We can also have different symbols. Maybe we can load in here into our type, and maybe also different lead arrows. Whatever you love, whatever you like, you can do this. Okay, great. So now let's duplicate this whole thingy, because duplicate's always good, and let's call this, for instance, PB. So that's my project base point. The project base point gets obviously the PB suffix here, or it's a prefix, PB, and another PB. So it's fantastic. So that's our PB one. But important is that our project base point has the origin actually the project base point. Here, by the way, you see that the relative actually pops up. Project base point, fantastic. Now let's go to the duplicate, and let's call it the reality point, where we are actually in reality in terms of the computer. And then let's make here the relative one. Have here this also switched to the relative one, and then have this also switched to the relative one. You will see that I will just play with a little bit of geometry, because whenever you're in doubt or have some issues or some struggles, just take your Revit and have a bit of a play with this. Nobody bites you, and Autodesk probably won't invoice you on the amount of lines you have drawn. So far as when this video was recorded, I didn't know or wasn't aware. Good. So I have here, for instance, our relative one. So you see, for instance, when we go to our type catalog, type select here, that we have our 3.1, and why this in the beginning, because in case the polygon menu becomes small, I still know what I want. Okay, so let's go, for instance, to my survey point, and then let's go to my survey point. Obviously, it's for my survey point. When I annotate my survey point, it's obviously 0, 0, which is good. So when I change this one here, basically back to my project base point, obviously we go from a project base point, and I can actually also select this here and becomes to my relative one, which is obviously the same like my project base point, because it's actually clipped to it, as what I just mentioned before. All right, good. So when I select this now and move this a little bit further away, a little bit closer, you see that they basically they actually update. All right, good. So when I, for instance, unclip this here, you will probably then see that I move this further a little bit away, and you see also that on the left top from this 3 that the project base point here actually also updates, but the relative one is still down there, obviously. So when I then unclip this, so when I unclip the unclip here, so when I clip this back on and move this, you see how actually everything moves with it. You see how the origin actually here, that the relation actually stays here, according to how I actually move my project base point relative to my grid line A1 down there. So some people ask, what is a good point for the project base point? Grid line A1. Every project has a grid line A1. If somebody doesn't work with grid lines, okay, invite him for a prayer. Say, okay, mate, you need a bit of a relation. Grid lines are actually not bad, and but in the end, well, you can't help it. A good point is, for instance, A1. What is a bad point? The center of the geometric center of your building. Why? You can theoretically import it into a geometric center. Also, any import, DWG imports geometric center, and it kind of might line up. But all of a sudden, during the whole design phase, the architect decides to change the size of the balcony, and then the geometric center is totally messed up. Okay, grid line A1 and nothing else. Believe me, it will always work. What might not necessarily work is to keep the project base point and the relative point always on top of each other. It actually doesn't matter, because the relative point is actually just required basically actually for the computer for that. When we want to export here our design as a DWG, we can go here somewhere to our export, to our DWG. Come on, let's see if this works here on this computerly. Export. No. Not today. Good. Probably something was selected here. Now it works. Good. So when we go here to, for instance, to our DWG, what we will find is that when we go here to our export setup, that we have here the option of units and coordinates. The project internal point is actually our relative point. Okay, the shared one is our survey one. Okay, just quickly, maybe if you want to quickly highlight this here. So my project internal one is actually here my relative one. All right, and the shared one is actually my survey point. So these two actually work together. When you want to export it, and you have maybe also survey plans, surveyors love actually to work in meters. So probably, obviously, if you want to work then actually in meters, just consider this. So this is our relative one. The project internal, if you want to export it, it's good. If you have maybe any elevations or if you have maybe any details, it is good. When it comes to any topography, if you have designed your topography, you want to export your topography, use please always your shared. Okay, theoretically the project internal we actually only need when we have any details or any small designs. It's not good practice to do this, to export the topography based on a project internal point. Okay, because we have always because we actually should have set up actually our site. Want to save any changes? Maybe later. Good. Let's leave this out. So hence the computer needs to have our relative one here, and that's basically cool because we actually want to work here with our project base point, because we actually can see our project base point. So our project base point. So then how do I get my project base point back actually to my 0, 0s theoretically? As soon as I actually type in here my 0, 0, you actually see that we actually go back to the survey point. So you see that actually works it out relative to my survey point. You see actually we don't see any big coordinates from about the relative point here. So unless I maybe annotate it, and then I can maybe actually find it or reverse engineer this a little bit where this is. So actually here then I can actually clip this back up here where my relative one is. Okay, so good. So what do we want to do next? We can actually set up different survey points somehow. I might have figured out here. So when we go here to our manage, somewhere we have actually some of our location here. And let's see if this actually works here. If I can get actually to work. And I have here, for instance, here different sites. They actually work back to our survey point. I need to bring this up here a little bit to our survey point. So when I now move these, we actually can here switch with different systems. And we have just seen before that is actually very interesting, because the project base point actually refers back to the survey point. So even if I have said here, that's my relative to my project base point, that when I click my project base point, then it's still that the internal coordinates of the project base points refer back to the survey point. Though even maybe my spot annotation actually was displaying 0, 0 here. And so it actually did not consider also the relative one here. Or good. When we just rename this here, and we just call it maybe geodetic world system, who knows, not necessarily, and hit the OK. We can actually also duplicate this whole thing, and say, for instance, here, duplicate this and say, grab maybe a different one. I think in 2004, I think it was revised to somewhere later. Hit the OK. And we just make this now our current one. So make this, for instance, the current one. Good. Have the current. So we don't have too many changes because currently they have been duplicated. They're actually the same one. So and what we now do is we just take this and we just move this a little bit further away down there. Good. So let's see if this now works. Otherwise I just need to start record from scratch and figure this out. Let's go here back to our site and say, for instance, I want to go to the 84 one and make this, for instance, the current one, and hit the OK. Pops, and we see that it actually jumped back here. We have here our nice coordinates, the 6132, 5547, and now we actually wanted to go to location, so we can continue with our recording and make this now our current one. And say, for instance, say we want to jump back, and we see that this actually also updates here the coordinates, and obviously relative to my project base point. So what does this mean? We can have here different setups, and we can actually also specify different setups on our side. We actually see that this is here actually also parametric, and hopefully it becomes a bit clearer now what I actually meant here before, that the relative one is actually based on is done by my computer, because relative to the relative one, I actually can move my survey point, for instance, to the left and to the right, and also I need to have my project base point where my geometry is being stitched to, that I move my geometry actually around. And the coordinates what we are actually reporting is basically given from our surveyor is what we actually fetch here relative between these two. If this would not be the case, every time that I move, the computer would need to run through the whole coordinates of the other entity, and this could be a bit pretty much a big miss, unfortunately. Because imagine if you have maybe 100,000 components and the computer has to update 100,000 components in their coordinate, it just takes time. And if I have a relative one in between, it actually makes it a little bit easier, so that the computer actually helps me to coordinate my model, and when as soon as a change comes in, basically in glimpse of a second, that we actually can update this. Good. So what's the big secret? What's the big story when we have, for instance, some huge geometry? Having said this, is actually not a big issue here, because it just considers our geometry and the radius basically from our geometry as what we have seen, as what we have heard, 10 miles. The only problem what can happen is when you get maybe drawings from a surveyor, that maybe the surveyor was so clever, and if so, just invite him for a beer and a prayer, and he might have had maybe some standard details down there at the origin. Revit doesn't know what this drawing is about, because it's just operated by a computer. It's an application considering I's and O's in a string. Okay, so it doesn't understand that this is a survey and there's standard details down there. No computer would understand this unless you tell the computer, because it's just a religious system. So having this down here, we will find that all of a sudden that the radius is much, much larger than actually 10 miles. So radius then much larger actually than 10 miles. Let's give this a little bit of a try here. I have here an AutoCAD open, and let's quickly design a drawing for us. Okay, and then let's bring it in. So somewhere is a tiny AutoCAD here. Boop. Fantastic. We see on the left bottom here a couple of coordinates. The coordinates are whatever we actually say the coordinates shall be. And we have just seen before that we have from our origin here, which is basically the one here on the left bottom, that we have our origin, we want to have our origin away further than actually 10 miles. 10 miles, 16 kilometers, so if I use just meters here, it would be 16,000 meters, something like this. So when I just punch in a line here, and come on, be nice to me. Good old AutoCAD. Still there. I need to just bring it over here again. And we have it, for instance, 16. So it means 16,000 meters, so to say. And bring it up there. Do a nice zoom all here. So 16,000, let's select it, it's still 16,000 meters, 16,000 meters, so basically 10 kilometers, and of course I go into the further into the other extreme, and then we go, for instance, 16,000 away. So everything away from our origin here, 16 kilometers, because we decide we want to have meters, in case if somebody thinks, hey, come on, we need to set up actually our units here, it does actually matter, so it's millimeters. These are just actually our insert scale units. Whatever we currently do doesn't matter. So what I will do now is here I go much further away. Oh, and then here we are. So obviously we have been much further away. So these are basically in meters here, our 32 kilometers maybe. But if somebody is now struggling, come on, we go just somewhere there. We just draw our nice boundaries, okay? So how large shall our section be? Let's say 500 meters and maybe 500 meters up there, that we just find it. And then this one we just delete. And then we can go up there and, okay, was maybe a large section, 50 meters by 50 meters, gives us still 2,500 square meters. It's a nice big section, can subdivide it, make a little bit more money out of it. Okay, sounds like a good plan. Good. And what do we actually also need to our section? Somewhere we need a road as well. So let's grab maybe here road, and how is it a byte road? Make it maybe let's say 7 meters, something around, and then we have maybe here also a tiny driveway. Good. And oops, so looks nice. So something around here we actually have. So a section is never actually true north and project north line up. So a section is actually never straight. So hence we actually need to rotate this thing actually also a little bit in a funny way. Let's say maybe 23.567 degrees, something like this, and then it might maybe look right. So then we actually need to have our true north maybe here as well, and then let's say our true north shall be maybe here, and then let's quickly mirror this quickly up there. Good. So AutoCAD here is obviously true north. What's the difference between true north and project north? Because when we actually go here in Revit, we find here our orientation project north, and we find it actually in true north actually together, project north and true north. For that, wonderful and great. So currently this is here in true north and project north. They're the same, and they actually project north is top of the screen. So basically project north means it keeps my building actually nice and straight, that I can use my ortho feature in the computer to draw a building straight, because mostly the buildings are straight. If I would go now to my true north, everything would be obviously in an angle, and this is what we see then a little bit later on when we stitch and connect our DWG or when we link it actually to our survey. Okay, good. So this is totally out of the square, huge nice coordinates here in meters. And so let's save this here, save this thing as drawing, and maybe on a desktop here somewhere where we can save this here, and then what we call it survey. And just underline meters, that we understand this. Bring this in, fantastic. So let's go back to our nice cool AutoCAD, and we want to insert this now. So if it's a survey, we can actually do two things now. We can either link it or we can import it. Everyone probably says link, 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 link. It's nice. There's just one situation, and it can happen on Friday afternoon. Somebody moved the survey and you have to issue it, and all of a sudden the drawing is gone and you can't issue it anymore. Also, somebody randomly overwrote the survey, and then all of a sudden nothing lines up actually anymore. The drawing looks really bad. So theoretically, what I would suggest is you import it into a Revit file, and if there's another survey plan, then you can just also import it and just keep it and basically link this Revit file in to work from actually. It works actually also pretty good. A little bit the philosophy about linking and importing. So ideally we find ourselves having here, maybe here, a nice DWG survey actually. Survey what we have. And we just bring this here into our Revit file, Revit database. And for instance, we can actually just import it. And then after the import, I have to do a little bit of a manual setup. Good. But ideally the survey actually should have given you a couple of coordinates anyway, because if the survey can't give you the coordinates, how should you ever know that what the survey gives you on file is actually right? The other option what we have is actually also to just quickly to link it in, and when we link it in, we actually can also connect it here to our survey point. It means that we can actually backwards acquire then our coordinates, and then actually our link is actually connected to the survey point. Good. So whatever is better, it's up to you. If you have a small project, link it. If you have a large project, I would produce a dummy Revit file in between, and from there on you can actually then publish or acquire your different project templates, because you want to keep them you want to keep the amount of files small anyway. So would be in the industry, find RAC, Revit Architecture, Revit Structure, or Revit MEP. Probably what is better, linking or importing, decide for yourself, whatever you need, whatever you love to maintain. If you want a good tip, large projects, import, small projects, link it. What is large, what is small, make up your mind. Okay, sweet. So that nobody sues me or is angry about me. If somebody doesn't line up, because in the end it's just the training. Okay, the training is the important part. Not if you link it or import. It doesn't matter at all. It's absolutely unimportant if you link it or import it. It's the training part is the important part. Okay, good. So having this now here, we wanted to link it now, because we just have a small project, because I want to show you how we can actually acquire the coordinates here. So let's link our nice cool CAD file here, and we find this under the desktop where we have our survey in meters. Obviously it shall be somehow in meters, which is good. So if I know the coordinates, ideally always check out and look up these coordinates prior. All right, good. So correct lines that are slightly off axis, this is mean because a survey is never straight. So, and we don't want to have for this current view only, we actually want to have this for all views, that I actually also see this in 3D. So orient to view, okay, sweet. It's probably a little bit further away if I would do so. So what I will do is here, I will just do it center to center actually, basically. So this means is, if I use the manual ones, this means wherever my mouse is, this is basically the relative origin then from my link. So let's just bring this here in a little bit center to center. Being on a level 1, everybody is happy, and then bang! Did anything happen? Now let's see and find out. So, opala, and here we see actually our beautiful nice import. Just our side is a bit larger. Yeah, as mentioned, we can a little bit subdivide it actually. So, having here our project base point, what we actually notice here, survey point, project base point, that as soon as I move this, that also my linked CAD file actually moves with it, which is cool because it's just that as any type of geometry. If it would be a detail, we actually also want to move our details with our models in case when we have this constraint. So it's being dealt and seen just as a simple piece of geometry. Good. Magic is actually happening is when I would go now to my manage, and somewhere we find an acquire function, and not this one here we want to go, and you say we want to acquire now the coordinates, because when I use the acquire coordinates from the DWG, the DWG origin becomes the shared coordinates from my file. It's pretty cool. So acquire coordinates, and we need to quickly acquire the coordinates from our link. We see that hopefully this is actually highlights it. Fantastic. So, and opala, where is actually my survey point? Somehow gone. Good. Let's see if we need to stop the recording, start all over again. When we go to the annotate, remember we had a couple of tools, spot coordinates. Survey point, bang, 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 quickly annotate it, and we see actually our huge, nice, cool, big numbers. And please notice that we actually brought this in even 63 something kilometer away from the survey point without any issues. Why? Because there was no geometry on my origin in my DWG file. That's why we actually had no issues. So hence we see we can actually bring this in without any problems. Okay, good. Let's quickly find out where the survey point actually is. Maybe we just want to get a little bit more project base point quickly on here as well. Project base points, you see why this is so cool. So you see still 0, 0, and where's the relative one, come on, be nice to me, obviously also 0, 0, because actually nobody, because we didn't unclip it, okay, or we didn't have any model correction or any site corrections where we had to move something, or yeah, good. Could be when, for instance, grid lines move. Because tidying up a grid line which moved is easier, and keep it always in grid line A1, then obviously we move it a little bit away. So when I double click now, we see actually here on the left bottom the survey point. So, having said this, absolutely cool, fantastic. Remember, if this still works here, when we go back to our location, actually, to the side, and so from the 04, let's go back to the 84, and say, for instance, make the current one, and hit the OK, boom, also stays down there. Why? Because it's being connected now to our DWG file. So that's one. So this is connected now to our DWG file, which is actually then driving here my survey point, and that's why it's down there. So when I would now annotate this down there, if somebody doesn't believe me that this is actually my 00, again, quickly go to our survey point here, and quickly click, click, click. It's a little bit small, sorry for this. We just need to zoom in a little bit. Yeah, it's a little bit huge, you see. We still have our 00 here. Okay, great, fantastic. So, how do I actually now, in my plan, do a zoom all and actually zoom to my model? For this, I just actually will need to switch off here my survey point, and I can do this actually here somewhere under my side. And we can go here under my survey point, to quickly turn my survey point off, hit the OK, gone, and now when I double click, actually everything is back up and running. Sweet, good. So also what we probably see is that is here still our project north, how this actually came in. Currently project north is also true north, unfortunately. So when we go here into my orientation, project north and true north is still actually the same. Project north can be shifted and moved constantly in any way without any issues, and you can move it 10 times around. It doesn't actually matter. The true north, of course, is the critical one. So let's say, for instance, project north, I want to quickly rotate this and shift this a little bit around. We can go to our manage maybe here, and these ones are actually down there. And we want to quickly rotate my project north, align the selected line here, bang, fantastic. And I can have a wonderful, nice, straight building. Probably I just need to set up my elevations again here in my project, but it doesn't matter because it's just I do this once in my life for this project and never again. Good, and so having these, for instance, here around, or I rotate this whole project. Ideally, when you rotate a project, theoretically, I would say around the survey point, yeah. It's probably the easiest. Now, let's practice this here a little bit because we want to test this. True north, bump, still my true north. And still a little bit here, my project north. Bang, moving this around as well. Good. So another thing did happen as well now a little bit. Unfortunately, is my my origins here. The project base point is listening to project north in XY. So having this one here. So let's assume we have here our survey point down there somewhere. So this is my project north. So this is project north, and project base point works together with project north in X, Y, and Z. So basically in X, Y. Z is always going up. Doesn't matter. So in X, Y. If I would use my true north, bang, go my true north this way up, these X and Y's we currently see here go and refer back to my survey point. Okay? So, and then for instance here a new one. And so these ones here, they actually, because we have actually here our true north, so true north goes back to my survey point with my X and Y. All right, the relative one goes back to my project one as well, to my project north. Okay, so they're a little bit closer. They're a little bit. There are some good friends. So it's for my true north from my survey point X and Y. So if you see that some of the coordinates might change or vary a little bit, this is because of this one. Okay, good, fantastic. So last thing what we actually want to still test now is what is actually happening when I now just get rid of this one here, and I want to actually bring in my survey point. Sorry, when I have my survey file, and I have actually a little bit of a geometry on my 0, 0. Then of course, then we have actually the issue for that. So I just a tiny circle, specify the center point for the circle, make 0, 0, 0, and the diameter, let's say maybe 50. Good. So when I now double click, we see something up there and we see something down there with my origin actually. So we pretend just that we have here a little bit of geometry. Then of course we get here a bit of a situation where probably Revit complains a little bit. So, and save as, and say survey extended. Theoretically maybe with details. Okay, also in meters, bring this in. Let's go now to our Revit here. And now we just want to bring this in here, for instance. Okay, let's link it again. The extended one, say meters, center to center. So, and now be nice, bing, and here we are. 33 kilometers, so it's greater than 20 miles, 33 kilometers. This may reduce reliability and result in and as a graphic behavior, obviously because the inaccuracy of our Z value. Good, when it actually generates it. Good. Bing. Yes, has been a warning, and then we just bring this in here, but this means that we still can bring this in. It's just a little bit of a large file. So what is now the best way when you have these type of large files here and you want to bring them still into Revit without any issues, without causing any warnings? Good, let's select this here and let's quickly delete it. And so we have it deleted, I think. And you can delete the details down there, but CAD files are dirty, especially when server just copy and copy and copy and copy data and extract data and delete data and just keep all details in their files. It's a little bit messy and chaotic. So what I would suggest is you just take this here, select what you need, turn on, turn off the layers actually you need, you might not need, and go to W, like wisdom, okay, to the W, and just create a tiny W block and then just quickly save it out. So we have our objects. We can theoretically also pick here another origin, but theoretically we don't want to pick another origin. We actually want to keep it actually on 0, 0, because otherwise our geodetic system is a little bit off. Important is just that we actually fetch here and decide actually a cool new name for that. So that's the W survey. Let's call it shall be also in meters. Let's save it and hit the OK. And then we can go here to our nice Revit DOM. Here we are back up and running, and then we can actually also go to insert. Where does this insert? Here in a link CAD. Fantastic. So W survey. Remember, we are dealing with meters. What about this? I can show you that it actually also works in millimeters. All right. If you're just further and far away. If nobody believes me. So meters, and then we have here auto center to center. Okay, this looks like a plan. And then yeah, why not give it a shot? Ding! Oi! What do I see here? That actually my little tiny thingy actually comes up again. Good. So let's see if we actually can now acquire the coordinates again. Oops. Yoo-hoo! A lot of things did change. Obviously, because we have our true north, we have everything now written. So if I have actually the survey, be aware that actually also here my survey can have a bit multiple setups. And whenever we have, for instance, some issues, or something is a little bit out of line, just select your DWG file go here to your shared site, default location, okay, and go to the default location here. In this case, if you want to move this survey to another instance, we can actually do this as well here. Whatever has been set up, good. And in this case, can we change it? Currently, this is our default location. If you have a second location, then of course the survey actually would also jump. Similar like what we did before with the manage. Something we can set up here as well. Yeah. But theoretically, we actually were then working with our survey plan, and not necessarily that we actually need to have the flexibility, but who knows. Good. So whenever we have something actually in place, the best and the easiest way is actually, and you have your origin here, to coordinate actually your model actually just with some raster graphics within the project. And this means, for instance, that we actually just take a tiny snapshot. With this tiny snapshot, we can actually also sign it off, mention here something when this was, for instance, done today with a certain time. And then we just save this file here. Save this as possibly, no, not this one here. So just save this here quickly, and under the desktop, and a little bit as a survey record. Save the survey record, hit the OK, and then what we can do is in our project here, we can just select this. And in our project, actually, we want to quickly insert here maybe a tiny image, and either we have this on a sheet where we actually don't print, or we can also try all kinds of other stuff here, so that we can bring it maybe here our survey record and just record this, for instance, here in our view. And so what we actually have here as an example is recorded survey or rastered survey. So whenever we need to tidy up any survey, that we can actually shift and move our stuff manually around, save our files, and connect and repair actually our files. So it's actually not bad to choose a couple of screenshots to repair actually your project. So hopefully this did help us a little bit, clarified a couple of things. Also myself, I learned a couple of things, and you have a wonderful, great day. Okay, thank you so much.